This training tape is designed to help you service your general pump, Interpump. You'll learn how to troubleshoot common system problems, how to spot mechanical problems, and how to service and repair your pump. But first, we'd like you to get to know your pump. Manufactured in Italy by Interpump S.p.A. and distributed by General Pump Incorporated, your pump is the most reliable of its kind made in the world. These are pumps of innovative design and proven superior performance. The unique Interpump design, with its forged head, multiple head bolts, locked wrist pin, and continuously lubricated dual packing system, has literally changed the manufacturing approach to pumps worldwide. And while other manufacturers try to imitate the Interpump design, only these pumps, with over 2 million in use throughout the world, have proven performance and durability. Of course, any mechanical equipment is subject to wear and requires servicing. However, you can be assured that your pump's problems will be less frequent and less serious than with any other pump on the market. The quality of your pump is assured by the method of manufacturing. At Interpump, quality control takes place before, during, and after production. The aim is a failure rate of 0. To ensure such reliability, every pump is thoroughly tested in 3 stages. At 50% pressure for 3 minutes, at full pressure for 4 minutes, and at 30% over the rated pressure for 3 minutes. One of every 50 pumps is completely examined and analyzed to make sure everything meets exacting standards. Forging and extra mounting bolts make the head twice as strong as cast heads to stand up to high-pressure spikes and freezing without cracking or warping. An inlet-outlet valve assembly with stainless steel valves, seats, and springs, all working within the unique design, make it efficient, quiet, and easy to service. Minor repair and routine maintenance is simple, thanks to the pump's practical design and pre-assembled repair kits. Your pump can be easily checked, serviced, and maintained with common tools, or even easier with special tools available from General Pump. In any pressure cleaning system, a high-pressure pump is just one of a dozen or more components. By itself, the pump does not create pressure. It is simply a mechanical device designed to efficiently deliver a specific volume of water with a given RPM. The pressure produced in any system depends not on the pump itself, but more on the source and amount of flow, and the control of that flow between the pump and the nozzle. Components of the system typically include an inlet water filter, pump and power source, pulsation dampener, safety relief valve, pressure regulator or unloader, chemical injector, trigger gun, and the spray nozzle. Any one of these components can be a potential trouble spot in a pressure cleaning system. Because the pump is the heart of the system, it is often the first suspect when a problem occurs. But in reality, most problems can be traced to components outside the pump. The pump depends on these components to operate properly. And more often than not, a problem in the pump is a direct result of problems elsewhere in the system. As with any mechanical equipment, an ounce of prevention is worth a pound of cure. You can prevent most problems and need for repair with routine preventive maintenance. Much like maintaining your automobile, many preventive measures are simply visual checks of oil and water. Your pump is designed to use SAE 30 weight non-detergent oil. In a new pump, the oil should be changed after the first 50 hours. Thereafter, every 500 hours of use. We recommend General Pump Oil, which is especially formulated to reduce condensation, foaming, oxidation, and rust. Check the oil regularly by both sight gauge and dipstick. A dark brown oil color indicates contaminated oil, which could signal that it's time for an oil change. If the oil appears foamy or milky in color, it means that water or condensation is present in the oil, and the oil should be changed. As we noted earlier, the pump has been one of many components in your pressure washing system. Therefore, it's important that all elements of the system be checked if a problem occurs. Don't assume that your pump is the problem. This can lead to unnecessary and time-consuming work. Begin with this simple checklist. 1. Is the power supply regular and adequate? 2. Is the drive system loose or worn? 3. Does your water supply match the output of the pump? 4. Is the inlet filter clogged? 5. Is the regulator or unloader properly sized and adjusted to the system? 6. Is the nozzle worn or damaged? If you have checked these items and a problem persists, you should now analyze the nature of the problem and the possible causes. While we will not cover all of the possibilities, these are the most common problems and their probable causes. Excessive noise is most often caused by cavitation. Cavitation can be caused by an inadequate or aerated water supply or excessively heated water. In most cases, a noisy pump can be attributed to worn valves, contaminated valves, worn packings, worn or loose connecting rods, or worn crankshaft and bearings. However, problems in the power end are rare. Excessive vibration or pulsation can be caused by cavitation, a faulty valve or packing assembly, or problems in the drive system, faulty belts, pulleys, or loose mounting bolts. Leaking oil is often a result of oil pressurization caused by failure to remove the red shipping cap and install the vented dipstick. Other trouble spots include an overfilled crankcase, leaky gaskets, piston rod oil seals, and crankshaft end seals. Water leaks under the manifold with no significant pressure loss could mean a problem with a cracked ceramic plunger, piston bolt assembly, or excessive inlet water pressure. A loss of operating pressure is a common problem, but most often the cause is outside the pump. A chief culprit and the first component to be checked is a worn nozzle or spray tip. Other causes include a faulty gauge, inadequate water supply, running at improper RPM, a faulty or contaminated valve assembly, and worn packings, or a combination of them all. Going through the 6-point system checklist covered earlier will most often reveal the cause of low pressure. The balance of this presentation will deal with troubleshooting and servicing the various parts of the pump. While your pump may differ slightly from the one used in our demonstration, there is a universal design to the pumps and their components. Therefore, the basic servicing concept will apply to your pump with only minor variations. Refer to your pump's data sheet for exact specifications. The training is organized in sections by title. You may wish to skip ahead to an area of particular interest to you, now or in the future. For this purpose, use the following menu as your guide. Valve assemblies, packing system, plunger system, piston rod oil seals, power end, crankshaft oil seals, and preventive maintenance. Your pump is composed of two main areas: the front or wet end, where the water flows, and the rear or power end, consisting of the crankcase and crankshaft assembly. Because problems in the power end are rare, we will concern ourselves mainly with the wet end. The wet end consists of three main elements: the valve assemblies, the packing system, and the plunger system. Problems with the valve assemblies often occur in a system as contaminants are purged throughout the new pressure cleaning system and flushed through the pump. These contaminants of the manufacturing process include bits of Teflon tape, brass particles, rust, and other foreign matter. The problem can be easily remedied by replacing the valve. Most often, the trouble can be located in the first inlet valve. Without removing the head, remove the valve cap and extract the valve assembly. Now check closely for the contaminant, which may be lodged between the seat and the valve. Also, look for a scoring or pitting. Such signs of wear would indicate a problem of cavitation or excessive heat. Repeat the process with each valve. While the valve assembly is removed, also check the O-rings for damage and replace as necessary. After extended use, you should expect to replace valve assemblies, for they are a wear item. For this reason, we have made replacement easy with a complete valve assembly repair kit. One kit is all you need to repair all valves. It includes O-rings, valve seat, poppet, spring, and retainer, all pre-assembled. First, install the new O-ring in the valve cavity. Next, insert the self-aligning valve assembly firmly into the center of the valve cavity. Now replace the valve cap and apply the proper torque. Repeat the process with each valve. To service the packing system, the ceramic plungers, or the piston rod oil seals, you must first remove the manifold or pump head from the crankcase. This section shows how to remove and then replace the manifold for any of these services. To remove the manifold, first remove the pump head mounting bolts. Now loosen the head by tapping gently on protrusions with a soft mallet. Pull the head straight off to avoid damaging the plungers. Do not apply any force to the side of the head. Now you are ready to service the packings, the plungers, or the oil seals. To replace the manifold after service, first coat each plunger with grease and rotate the crankshaft as shown. Note that the center plunger is drawn in, while the outer plungers are extended, forming a stable guide for remounting the head back onto the crankcase. Again, handle the head carefully to avoid damaging the plungers and packings. Now replace the head bolts following the proper sequence as shown. Use a torque wrench to torque to specifications. Do not over-tighten. To service the packings, first you must remove the manifold as we've shown. Because of a superior design, the packing system is exceptionally durable. Therefore, complete packing system replacement is seldom necessary. Most often, simply replacing the V-packings is all that's required. To accommodate various needs, different packing kits are available. A full kit includes front head ring, front V packing, one long life ring, brass intermediate seal retainer, rear head ring, rear V packing, brass main seal retainer, and O-ring. Individual packing component kits are also available. To remove the old packings from the head, first insert the proper extractor collet through the main seal retainer. Tighten the collet and extract retainers, V-packings, and head rings. This special extractor tool makes the job easier. If conventional tools are used, be careful not to scratch the brass. Carefully inspect the O-rings, packings, and long life rings. Look for wear and chipping. Chipped or cracked packings are an indication of system-induced wear from heat or cavitation. Examine the brass for deep scoring or excessive wear. Because the brass components are critical to the packing system, failure to replace warm brass parts may cause improper piston guidance and premature packing failure. Now reinstall the parts in the proper order using a packing insertion tool. First the front head ring, and then the front V packing. When installing the long life ring, note that there is a slight bevel to its shape. This bevel should fit snugly over the contour of the packing. This is important to ensure the durability of the high-pressure V packing. Now grease and install the intermediate seal retainer and the rear head ring. Now replace the rear V packing in the main retainer and install the main seal retainer with O-ring into the manifold. Thanks to the unique Interpump design, no additional adjustment to the packing is necessary. Finally, reinstall the manifold head as we've shown. Before doing any disassembly, examine the pump closely for evidence of a water leak or an oil leak between the wet end and the power end. A water leak would indicate a cracked ceramic plunger or a leaking piston bolt assembly. An oil leak would indicate worn or damaged piston rod oil seals. To service the plunger system, first remove the head from the crankcase. Now remove the piston bolts from each of the ceramic plungers. Gently hand turn the ceramic plungers and remove them. Now carefully remove the copper slinger washers. Examine the washer closely, looking for signs of wear or damage. With the slinger washers removed, inspect the pistons for water stains which could indicate a cracked piston. If a crack is found, replace the ceramic plunger. After you've inspected the washers, piston bolt assemblies, and ceramic plungers, and corrected any problems, replace them in reverse order. Whenever the plunger bolt system is removed, the copper washer and slinger should be replaced. Carefully insert the new slinger washers with slot down, then each ceramic plunger. Before replacing the piston bolt assembly, apply a small amount of Loctite number 271 to ensure proper seal. Hand tighten and then torque to 14 foot-pounds. Use a torque wrench. Do not over-tighten. Now replace the manifold as we demonstrated earlier in this videotape. If you detect an oil leak in your initial inspection, the problem may be with the piston rod oil seal. The piston rod oil seal can only be replaced with the ceramic plunger removed. First, carefully remove the manifold. Then remove the piston bolts, ceramic plungers, and the copper slinger washer as we demonstrated. Manually rotate the crankshaft to draw the piston rod into the crankcase as far as possible. Insert a small straight blade screwdriver under the inner lip of the piston rod oil seal, being careful not to scratch the piston rod or oil seal bore. Rotate the screwdriver into the oil seal. Now turn the crankshaft so that the piston rod moves away from the crankcase. The oil seal will be pulled from its seat. To install the piston rod oil seal, use an oil seal insertion tool or an appropriate deep well socket that clears the piston rod. Lubricate the new oil seal and carefully place it over the piston rod. Use a socket or oil seal insertion tool to set the seal in its seat. Repeat the procedure for each piston. Whenever the plunger bolt system is removed, the copper washer and slinger must be replaced. Now replace the plunger assembly and the manifold as we demonstrated. The power end, consisting of the crankshaft assembly and crankcase, is more complicated and more challenging to repair than the wet end. Fortunately, the power end is also much less likely to have problems and need repairs. Problems with the power end are rare because the pump is designed for maximum durability. All general pumps feature a large capacity cast aluminum crankcase. Large full-contact connecting rods with a locked wrist pin of proven durability. Oversized ball or tapered roller bearings. A non-elastic forged crankshaft. And hard chrome-plated piston rods. Problems in the power end, while rare, usually require special tools and equipment. If service is needed, please consult your General Pump U.S. representative. An oil leak in the power end indicates that the crankshaft oil seals need to be replaced. To replace the oil seals, remove the 4 screws that retain the crankshaft cover, and with a flathead screwdriver, remove the cover, taking care not to scratch or nick the brass shims or the crankcase. Remove and examine the bearing cover for any cracks or imperfections that would cause an oil leak. Keep the shims in proper order for reassembly. Now examine the O-ring seal for cuts and abrasions and replace if necessary. Using an arbor press or appropriate socket, push the crankshaft oil seal out, taking care not to damage the bearing race. Press the new crankshaft oil seal into the cover, facing the same direction as the one you removed. Oil seal lips always face the oil reservoir. Now reassemble the crankshaft cover, making sure the shims are replaced in the same order in which they were removed. Follow the torque sequence as shown. Torque to 15 foot-pounds using a torque wrench. Do not over-tighten. Your pump is designed and built to serve you well with dependable performance and uncommon durability. Properly used and maintained, it should give you many years of trouble-free operation. But like any finely tuned machine, it requires regular care and an ongoing preventive maintenance program. Regularly monitor your oil sight gauge and dipstick for dirty or discolored oil. Change the oil every 500 hours. Watch for signs of condensation in the oil. If and when servicing is necessary, follow proper procedures as outlined in this training film, taking care not to damage any parts of the pump during the servicing. You have the finest pump of its kind in the world. Designed and manufactured by Interpump S.p.A. and distributed by General Pump Incorporated, your pump is built to last and designed for easy maintenance. Although occasional servicing may be necessary, you can count on more years of uninterrupted service from a General Pump than from any other pump on the market. When it does require servicing, superior practical design and pre-assembled repair kits make the job easy. Interpump and General Pump, proven quality pumps, designed and built with you in mind.